this question, what we want to do is determine if each of these functions are of exponential order. So what that means is if we can find values m, k, and a such that this inequality is true for all t greater than or equal to m, then this function is not of exponential order. And if we can't find any values m, k, and a, then the function is of exponential order. Okay, so let's start with the first part here, part A. So now what we can do here is we want to find values m, k, and a such that this function ft is less than or equal to k e to the at. And if this is true for all t greater than or equal to m, then this function is not of exponential order. Okay, so what we can start off doing here is we know that no matter what, sine 3t is always less than or equal to 1. Because a sine of any value has a range of -1 to 1. So what that means is that e to the 5t sine 3t is less than or equal to e to the 5t. For all t, just to make it simple, we'll just consider for all t greater than 0. But it should be true no matter what. From this fact here, we can find some values m, k, and a. If we set the value m to be 0, if we set the value k to be equal to 1, and then if we set the value a to be equal to 5, then we have ft is less than or equal to e to the 5t for all t greater than or equal to 0. This function is not exponential. Okay, so now let's look at the second part, which is e to the t cubed. And we want to try to solve that same inequality. We have e to the t cubed is less than or equal to k e to the at for all t greater than m. So one thing we can do is that if we let k is equal to e to the c for some constant c, we can rewrite this as inequality as, and then we can take the natural log of both sides to get. So now what this means is we want to find values of a, c, and m such that for all t greater than or equal to m, this inequality is true. But we can see that no matter what value we have for a or c, as t approaches infinity, this left-hand side will grow faster than this right-hand side, no matter what, because there's no choice of a and c where t cubed will grow slower than this linear function. So since we can't find any m, a, and c's such that this is always true, right, for t greater than or equal to m, just to recap what I'm saying here, this cannot be true as t approaches infinity. So thus this function is exponential.